So let's continue with our exceptions. So we saw that there is also a runtime error, which is sort of like generic exception already predefined. It's actually a subclass. It inherits from a more generic exception class, actually, right? And today, in this part of lecture, we'll see about defining our own exceptions. But again, the thing is, it's annoying. You have to throw them yourself if you are doing it, right? So if you divide by 0 without checking, it's not going to be an exception. It's going to just crash, right? We can try that immediately here, right? Before trying, right? If I throw here, let's say if I do this here, right? Let's just divide by 0 by b without throwing. Yeah, this will crash. So right, so this will crash, right? So that's probably in Python, this would throw a zero division error. We don't have such luxury. We have to handle it ourselves. In C++, we have to do it checking ourselves, right? Again, it's because, of course, C++ is a relatively lower language. Again, it assumes maybe sometimes you really want to just go ahead and plow through, and everything is just peachy. Okay, let's do that. Let's crash the program. Right, and let's see, except 9000, that's nice, but let's do 3 is nice, but 0 floating point exception, core dumped, right? Well, it is an exception, unfortunately, we're not handling. So could we have handled this, right? Floating point exception, core dump, right? I mean, it looks like an exception, actually, right? Maybe there was a way. Now let's see. Could we have handled? Because, well, what happened, of course, this is, right? Could we have handled it? Arithmetic exception, right? Could we have handled this, right? Could we throw it? Could we handle this? Yeah, right. I thought, because it's kind of a little bit a floating point exception. It seems like there might be a floating point exception. Could we handle it? Let's try this one more time. Catch. I don't think we can catch anything. Right. Yeah. Yeah, we can catch it, right? Let's see this, some other exception caught. Will that work? Look at these ellipses, right? Kind of silly, interesting example. So this catch block, not always, sometimes catch, sometimes, yeah. Usually we do not, yeah, we would want to rethrow. Yeah, we do not just want to handle, like nothing happened, That would be really bad practice. That would be bad practice. Leads to what? To bugs and silent failures, right? So that's why, again, so this is kind of very tempting block to use, right? Then of course you catch all errors in bucket, right? And don't worry, you just keep it going. But usually, of course, you want to crash, and then you want to crash, right? Okay. On the, let's see what happens. Let's see what's going to happen. Is it going to handle this? Is it going to, I wonder. No, it didn't actually. It didn't handle it. So this actually, so it looks like floating point. It says floating point exception, but it was not caught by this, right? So it was not caught by this, right? So I will. No, we cannot. Alright. Now exceed success. Alright, so let's do a custom exceptions. Like, let me combine more exceptions. All right. Now, let's do one more exception. Custom. I'll call it custom exceptions. Custom exceptions. Or I guess I should. Let's write our own custom exception. We will call it invalid age exception. Right. All right. So what do we need to do? We need, of course, IO stream. Right. We need to include exception. Right. I think include exception. We could have included exception instead of runtime error, right? I think that would work as well, right? And include string. Come on, string. Yeah, we want this. Yeah, for string, of course, right? So now using namespace because I'm just lazy, right? And let's define our custom exception, right? So this is something we are going to be subclassing, right? So class invalid age exception is going to be a runtime error, could be exception, right? I guess I'll do exception, right? I'll do exception maybe. Maybe I'll do that instead, right? This is not fine. It's fine, but include exception. Right? Because again, so what's runtime? So runtime error, runtime error is subclass of exception. Yeah. So I'll do public. It's public, right? Public exception, right? All right. So we by inheriting from exception, right? So what do we need inside? We need a message, right? We need a message. It's going to be private. By default, of course, it's private anyways, right? A message, all right? So this will be a custom message for the exception, of course, right? And now the public stuff starts, right? Public, right? Remember again, classes, everything starts private. It's, in classes, private is default actually. Default, but yeah. And now public. So we want a constructor that accepts a message. We want a constructor. Right. So basically, I don't like this part here. It should be constant actually. Const and I believe at. Why? Because we don't want to modify this, right? Now it should work. I think. Yeah, but or not. Message, MSG. Or am I not doing correctly? Am I doing it wrong? Maybe because you don't want to modify it, right? Let me see if I made this mistake somewhere. We'll try to compile custom message. We're not doing anything with this. We're just passing it through. Oh no, it's fine. No, it's not fine. Where's my, I need to close it, of course, that's no big deal, but I need to close this, right? Okay. Oh yeah, we're good, all right. So, all right, we don't want to, constructor, we don't need this constructor, we do not modify, we use const reference. Okay, so it makes sense, right? It will initialize this, so it will, this constructor will initialize the message or private with the MSG, monosodium glutamate, right? All right. So, what else? So is that all? Are we done? Not yet, unfortunately. We need to provide our own. We're going to override. What's overriding? There's a regular what. So, what? Exactly what? That's a what function, right? What member function, right? So we need to also need to override the what function. So what is the member function? for exception, right? So again, const it returns unfortunately it returns a C-type string, or not a regular string. So yeah. So const and char, yeah, what? Constant no exception override, right? So we return a custom message, basically message C string, right? We're storing a string, but of course we could do more things here. We could log external file. We could send an email to the developer, right? We could, right? Email the user, I suppose. We could crash. We could launch a rocket, a missile, of course, right? And or we could just prepare this message to be slightly friendlier, I don't know. Okay. All right. Well, okay. So that's the basic. That's our basic. What you need for the homework, basically, right? And now we do this. So now let's do a function. Yeah. Let's do this, right? So we pass a message, try, if age less than 0 or over 150, let's see, invalid age, and right, that's our own new exception, right? And basically we need to handle it, of course, right? Right? Now here age is good. We catch, right, and it will run it, right, evat, right, and this will basically do string. So yeah, but of course more things here, but it should not be done in what usually, right? What is for format returning the message, right? Right. Yeah. Right. So depends. So probably here you could do some weird things. So I would say probably I will do this. Yeah. Okay. Now let's catch these exceptions. Right. And now here, of course, return success. Return exit success. I like this macro. Okay. Now custom exceptions. So G++ val custom and allowed custom C except. I'm lazy. Yeah, exception code invalid age is 200. Right, so not good. Right, we could of course also, again, since I'm lazy, I'll do again argument count. Arg count, right? Arg vector, come on, int. Yeah, like this, right? And I'll check, right? Let's assume what's our default. Let's do age 20, right? Assume it's default, right? Some default. We'll now check if. Yeah, and now age equal. Let's assume we assume that babies have positive age, right? So baby is not 0; they'll have, I guess, 1. I don't know. That's in Korea. I think in South Korea they do the count. I guess everybody gets the same birthday or something like first of like. Right, so they have every same one. They count the years, kind of weird, right? I guess it's not the same birthday, but the age is like weird. They start from same day or something. Okay, now age over 50, kind of very optimistic. Okay, and let's run it now. So now I can pass. Some age, right? I can test some ages, right? So let's do it. Yep. And I can run like with nothing, It's 20, edge 20, nothing, no big deal. Success, right? Success, right? Of course, right? I could do something like 122. That's the oldest age, right? That's fine. But if I do 152 invalid age, and if I do 0, it's also minus, minus 55, right? So yeah, so that's how it works. Really simple, actually, right? You basically prepare a message here, right? On the logic of handling, the error should be left for the catch blocks, right? So, and again, like I said, the question was from a colleague, right? So that Atoy, right, does not actually give you an exception, right? Let's double check if I was correct. I think it was, right? C++ reference, Atoy, right? Can you get an exception out of it? Sometimes you need to check. Yeah. If the value of the result cannot be represented, the converted value above half of the range of corresponding return type. No. If no conversions, 0 is okay. So, yeah. So it's either you either get an integer or you get a big fat 0, right? So that sounds fair, right? Yeah. The thing is, that mentions, if you read about this, it's C++ library falls back to the C library actually, right? So again, you can try. Some things will work, some things will not work. The thing that I don't like about this approach, of course, is that 0. It's kind of a little bit dangerous, this Atoy, because sometimes you don't want to get 0, right? You actually want to fail, right? Because maybe 0 might be a valid value, and here you sort of like assume that 0 is always going to be a good, you can't distinguish between a real 0 as a regular integer and also like a just complete bad value, right? So that's kind of a little bit messy, right? I would say better would be to actually raise some exception, but unfortunately Atoy does not do that. Is there anything that raises this? Because we can't distinguish how to alternatives. So Atoy that raises exception, right? I think there might be. Yeah. Yeah. Well, this looks like AI plus. Because it's you don't know, you'll get 0 right here. So this guy looks this is like 13 years old. Let's look at this guy here asking, right? Yeah. Right. Because look at this guy here, right? He's trying to catch something, right? Atoy does not throw exceptions, exactly, right? And because of course Atoy is in C, and C does not have exceptions, right? So it makes sense, right? Because see, that's a problem, right? But there is actually a standard Stoy, right? Let's try that one, and that would be nice, right? That would be actually quite nice, right? Let's try this one, right? Right? Let's try this one. Let's try this one. And we will try it in here, right? Right, and I will do it here. So let's use standard. Yeah, because Stoy throws an exception, right? So try on age. Yeah, and we need to catch. We need to handle it here, right? All good. Yeah, catch invalid argument. I think it's all invalid argument. I can, yeah. Right, out of range. I don't know if this is out of range. Okay, or boundary checks, but I don't know, of course. So these are actually. So this is kind of good. So you need to read about the story, right? So that's kind of would be, if you want to catch these things, right? Then you use Stoy because it's already defined, right? A toy is from C, yeah, it's from because a toy is from C, and C and does not throw exceptions, right? So let's try this one. So here we know age is good here, right? The only problem, of course, is now we should probably do returns, return. What can we do here, right? We don't have valid age, right, at all, right? We could do it in a while try while block, right? Make for, well, but we don't have an input. This is actually not input. This is actually well, we just have to return fail. We know nothing to do. We can't do anything with age here, so let's return exit fail, right? Again, nothing. Return exit fail, right? That's minus. That's positive one. Okay, that's something we could do, right? Let's try this. Let's do some bad things with input. Okay, compiles, and I'll do like Valdis. So Valdis is gonna throw an exception. Yeah, exception code stoy. Right, stoy. Right, stuff here. All right, so and right, but this of course slightly, it's not custom exception. It's actually part of the standard library, right? But this is actually more. We're talking more about our own invalid age exception. Invalid age, right? So let's see what the slides say. So let me commit this. Custom and standard exceptions. So again, another piece of advice. You see how it's always use a toy because, well, you don't have to handle exceptions. You get 0. But again, you have to consider whether 0 is appropriate if somebody enters, their name or whatever strings, sometimes it's okay, and sometimes it might be completely bad behavior. All right. So derived classes. Actually, there's a lot of slides still to look. So to sub logic error, yeah, you can have use standard exception, use logic error, right? Invalid argument, out of range, length error, overflow error, underflow error, right? You can use your own exception classes, which we did. So basically, you would need two things, constructors and the function what, right? So throw, yeah. By the way, yeah, you can rethrow this, right? So this would be legal, would be to throw it here, right? Where we dot, yeah, invalid age. I think it was. We catch something else, right? I don't know what we could catch here, right? Out of range, right? We could rethrow it, for example, right? And it will not be handled, right? We could do that. We could have rethrown with throw. Simple throw. You could also throw new exception. That's also possible, out of range exception, but it's not going to be handled. It's going to basically go out, right? Let's try this. So exit is not going to run, right? So you're not going to get to this part here, right? Because you're throwing exception, right? More throw. Yeah. What can you throw, by the way? Yeah. Well, pretty much anything. Well, a specific object, anonymous object, right? So you throw, basically, typically, yeah, the clause. Here, there's actually how it's done, right? It's a void, right? So terminate, include code to recover, or log the error and continue, right? So 3 choices, basically. So terminate. If input file does not exist, well, what's the point, right? You can't do anything, right? Appropriate error message and terminate. Fix the error and continue, right? So let's do that. Let's make this classic for input handling, right? input with exceptions. Let's show an example of handling user input with exceptions. We want to get an integer from the user, right? We want to throw an exception, and we want to continue to the give us one, right? Let's do that. Events 3. Yeah, I guess. Right, void, right? So it's going to be while true, right? Yeah, okay, right? So while true, right? So stoy, right? We try to convert. We now, so this is very similar to how Python does it, right? Very similar to Python, right? And so we catch, right? So we break out of the input loop if we have a valid integer. So this is the standard approach, right? We know this is going to be a number, right? Right. Otherwise, we are going to out of block. I wonder what's going to happen if okay, let's try this, right? So this is not a custom, this is just regular exception, right? So we're using a standard conversion, right? We catch invalid argument. This means probably exception code, you know, invalid argument, right? And out of range. Okay. Now let's try this one. And then finally you can do now of course do whatever you want with the num here, right? Okay. So user input on u input. All right, and it's going to ask me enter integer. I'll say val this invalid argument exception code. All right. So okay, let's do this, right? That's probably too big, right? So okay, no, that's okay. What's happening there? Okay, enter. Right, very good. So it said this is not fit into integer, right? Also, so we have two different catches, right? Can we do anything else? Can I do like minus something? Probably two, right? Oh, no, that's fine. Well, let's see what happens here. Is this gonna work? Yeah. Okay. How about what? Okay. How about this? Unval this, right? Okay, you see, that's interesting. So why does this work? Well, because this actually, remember how streams work, right? So this will work because the stream still has a buffer, right? Notice also, note that input will be a string, right? You know, of whatever length. Until they hit enter, right? So what's interesting is that, so trying print, so attempting to convert, right? To show you what we're going to do here. Let's try this one more time. On user input, on so 5000 RBS, right? Oh yeah, of course, 5000 RBS. Yeah, so it works, right? Because, well, this part here works, right? So now, so this is it. So if I did, of course, right, this is not gonna fit RBS. That should be a fail. Yeah, out of range exception, right? And if I did something like just RBS, of course, also invalid argument. So there are two possibilities, right? I don't know if there's anything else I could do to break things. I guess I can't, right? I could do this, invalid argument, right? Minus 5000, that's fine, that works. Okay, so hopefully this example shows how you can handle invalid arguments. This is a classical while loop, right? And force the user, poor user, to enter something. Okay, let me save this. User input with exceptions. And I think that's almost done. Log the error, right? So we could log, yeah, if you do a nuclear reactor or continuously monitor satellite, you can't really terminate the program, right? You have to somehow recover, especially satellites, right? Sometimes, you write program well, you can recover even from things, where really cosmic stray race, right? You keep doing and hopefully hope for the best, right? So do nothing, right? Partially process exception, so either throw the exception or throw a new exception, right? So again, the stack and binding, right? You have a new block for checking the exception, right? Yeah, so if you don't handle exception, the function terminate is handled, right? So let's review this. So a quick review. Exception is undesirable, right? Assert is actually for check is like it's not an exception, but it's your check whether the expression meets specified condition, terminates if not met. And try catch block handles exceptions, right? So you should be throwing things, right? You throw the exception, right? And you specify if you want to do your own exception class, which is what your homework will be, right? Where's the homework? Where's the homework? Here you go, right? You need to throw those invalid day and invalid months, maybe invalid years as well, right? But notice, right? So you need to also, of course, parse it, right? It's it's not too hard. Also, for full credit, you want to handle these leap years, right? It's possible. There are nice libraries to handle this, but you still need to do your own exception classes, right? You can do the parsing, right, using some built-in libraries. That's completely okay, but throw the things your own exceptions. Okay, let me see if I can say. Okay, I commit this. Let me see if our repository is updated with these topics. We have assertions and we have custom exceptions, and we have a user input with exceptions 2 minutes ago. Okay, very good. All right. Okay, what else do we want to do? Terminate. Is there anything to mention this function terminate the program? I think it's built. You cannot have custom terminator, I don't think. All right, let's see if there is C++ reference terminate function. Yeah. So IBM says and C++ reference says. IBM says void terminate, right? So you don't write. You do not write your own terminator. I don't think so. Yes, set terminate. You can actually call to my terminate. Oh, that's cool. You can call your own terminator. Right, that's actually, there's something with C. Right, let's see. Set terminate. Double check. Is this C++? Oh no, this is C++. But this, of course, is some IBM version. So let me double check. Is this set terminate? I'm not 100% sure this is all standard. Well, let's double check. Is it? Yeah. Basically, yeah, you can. Okay. Sure, if you want to make your own except handler, right? Right. So you can throw one, right? You don't handle this, you throw something, right? Core dump, right? So basically, right? So let's look at this here. So let's example your own terminator. Well, that's kind of cool. No, I don't know how useful it is, but you might want to. Terminator. Plus, yeah. We can set your own terminator function using set terminate. All right. Exception. Do you want it? Okay, well then I was gonna say, okay, let's not do that. Let's do this just a simple Terminator. Let's just write our own Terminator. We call it custom. We will call it T800 or something. I don't know, right? I don't know. Yeah, I'll be back, right? Oh my God, all kinds of things. Look at all the nice AI brain dump. But for now, we will just abort. Yeah, which is from here, right? And that's it. But now, of course, right? Void T800, right? Let's use it. Now let's use it in main. We'll just set up, right? So we pass a function pointer, right? So we pass a, so set terminate. If you look at this here, yeah, you type a pointer to function of type set under terminate handler or null pointer, right? So let's see if this works actually. Let's see. Right. Oh, this is anonymous. This is anonymous. Right. So this is void or null pointer. I wonder if this is gonna work, right? Because this is a terminate with this is anonymous function, right? But we want to actually pass it, right? Let's see. This is gonna be legal. Did we actually void? Yeah, void. It's void. Okay. We are passing a pointer here, right? Now let's run it. Right. No catch to handle it. Right? CO normal. Right? Okay, let's take a look at this. I just want so we'll be finished. So Terminator. Let's see if this compiles. I don't know. Again, I like to break things, so as we know. T800. Oh, it compiled actually. Fantastic. I'll be back. Aborted. Core dumped. Right. Okay. That sounds ominous, but it works. So yeah, if for some strange reason you want to do this, it's possible. Again, C++ pretty much has everything, right? So yeah, you can say, okay, you want custom Terminator, there you go. Okay, that concludes our exceptions, right? We covered more than usual. This is not required to write your own custom Terminator. So I will add this. Any questions on exceptions? No? All right. So what do we do next week? We have, as far as, we'll be doing some, I think, data structures, I believe. What is this, 766, right? No, that's algorithms. Algorithms, we are doing graphs, but for data structures, let's see if I want to change the order maybe a little bit. No, yeah, we're going to do a linked list, finally. Yes, our friend linked list. And, well, we'll see. We'll deal with some how nasty linked lists can get, actually. Not too hard, but still. Okay. So thank you, everyone. And have a great weekend.